Okay, so layer 5, session layer. Session layer manages session establishment, maintenance, and termination between network devices. Example, when you log on or log off, again, we go back to that phone call analogy. When you start up on a phone conversation, hello, how are you? You initiate the conversation. I've called about blah. Hey, Christopher, I've called about this presentation. So Christopher would answer, we'd go back and forth, and then when we were finally finished, you'd be like, okay, goodbye. And then if he had a decent session layer protocol, he would say goodbye also, and we would cleanly disconnect the session. This layer also controls the name and address databases for OS, such as NetBIOS. NetBIOS, Network Basic Input-Output System, is a protocol that works at this layer for naming, creating names and associating names to computers. And actually, Microsoft was one of the people or one of the companies that implemented this for a way to associate names to computers.
Yep, a long time ago. This was one of the protocols Microsoft implemented. It's not so widely used anymore, but it's still out there. You'll still see it.
Layer 6, the presentation layer, translates data format from sender to receiver in various OSs that might be used. Concepts include character code conversion. Remember I mentioned maybe ANSI versus EBCDIC, the different keyboard types. Or not necessarily keyboard types, but data representation. How do you represent an A in this system versus how do you represent an A in this system? Presentation layer is the one that translates that. Redirectors work at this layer, such as map network drives that enable a computer to access file shares on a remote computer. Again, a translation system. And then finally, layer 7, application layer, serves as the window for users and application processes to access network services. End user protocols, FTP, SMTP, Telnet, and RAS work at this layer. Again, this isn't supposed to be confused with the application that you're working with. This isn't mail. This isn't the mail UI that I'm using. The mail UI that I'm using that sends information down the stack, it hooks into the application layer. The program itself isn't the application layer. And then again, the OSI model revisited. If we take a look at the slide here, we see application, presentation, session, transport, network, data link, and physical. We see the different protocols associated with each layer, and then different devices that might be associated. One thing to keep in mind, or that I always thought was kind of interesting, is notice TCP and IP are at different levels. People think that TCP and IP are opposite of the same thing. They're actually not. It refers to a portion of the transport protocol and a portion of the network protocol. In the scheme of things, not overly important, but a fun geek fact.
Again, ways to impress your friends at parties.
Exactly.
We're chock full of ways to impress your geek friends at parties.
Obviously, Christopher and I don't go to a lot of parties,
We do not.
but if we did, we would have knowledge to share with you and would be happy to do so. The TCP model. So we've talked about the OSI model. The TCP model is actually a little bit different. It's similar to the OSI model, and it allows interconnectivity between devices and allows intercommunication. The TCP model is only comprised of 4 layers. The application layer, which defines the TCP IP application protocols. The transport layer that provides communication session management. Internet layer, packages and routes data. And then the network interface details how data is physically sent through the network. Something interesting about the TCP model is that the TCP model doesn't really designate on the OSI level a physical or data link layer protocol. They only give information for the upper layers and then figure, hey, data link and physical, we're not going to worry about it. We're not going to worry about those layers. Other companies or other areas can worry about that. We're just going to worry about the upper level transport. Let's take a look at the OSI model compared to the TCP model. Again, you see here the OSI model, 7 layers, the TCP 4 model, 4 layers. The application and TCP model is equivalent to the application, presentation, and session layer in the OSI model. Transport layers are equivalent. Network layer routing in OSI model is similar to the internet layer routing in the TCP model. And then again, the network access layer in the TCP model isn't really concerned. They're like, oh, okay, well, you can use Ethernet, you can use FDDI, you can use whatever you want. We don't care. We're more concerned with the upper levels. And most of you probably already know this, but if you don't, TCP/IP is the protocol used for internet standards and is the protocol used for internet communication. Wow, we're at the summary already. Who would have thought that we'd got through all this information already?
Time flies when you're having fun.
It flies sometimes when you're not having fun, but hopefully everybody's having a good time.
I wish you did that more often. Yeah, they better be.
So basically the summary here, understand the OSI model by defining each of the layers from a theory perspective. 7 layers: application, presentation, session, transport, network, data link, and physical. I see Christopher over here like ticking them off as I go down. Priest saw 10 nuns doing push-ups, was kind of going through in my head. You need to be able to separate the functions of the lower levels of the OSI model from the upper levels where message creation